Okay. Thank you very much, Mattia and Timothy. And good afternoon, everyone. My name is Zhengxiao Ying. I'm a data scientist at Algonomia. We are a tax technology company based in France that provides digital solutions for tax management in large M&Es or small, any kind of M&Es. So first, a little bit about myself. I am also not a tax lawyer. I'm more of a technical person. So my academic background is actually in science and engineering. But before moving into tax technology at Algonomia, I worked for several years as a transfer pricing consultant at EY Tokyo. And today, I'm presenting with my colleague Youssef Balma, our lead developer at Algonomia. So I will walk you through our study about turning tax law into machine-executable data, and then Youssef will show a live demo of the application of our study. So our project actually started with from a very concrete request of a client who is a tax manager at a large M&E who was coordinating the transfer pricing filings across the whole group. And what they want was to automate the process. So instead of chasing documents of regulations, they want to some system to automatically generate a transfer pricing compliance calendar to know which entity needs to file which type of TP obligations and by when across around 100 jurisdictions. So what we noticed that the biggest problem is that the TP compliance information was not structured enough. Most of them was hidden under narrative text. So we realized that for automation, the key is not to collect more data or ask LLM to generate text summary, but to turn legal text into computable, structured rules that a computer can apply the same way every time. So for tax teams with this kind of structured rule, when they input their entity's data, the computer can automatically generate TP compliance calendar data. And more broadly, once rules are structured, it's also much easier for tax administrations as well as academics to compare different tax regimes across jurisdictions and also measure something like tax complexity, which I will come back to later. So once we have extracted all the structured TP rules, we did not want to keep them behind a paywall. So we decided to initiate an open source and open data project called Open Tax Calendar, meaning that the data is free to access for everyone. We also funded the nonprofit Open Tax Society to manage this database in a community-driven way. So on the platform, you will be able to browse the database from different sources or different jurisdictions. You can export the data in PDF files or Excel files. You can also make distributions to help us improve the database. And Youssef will show you more later in the demo. So now you may wonder, how did we actually get this data from hundreds of, if not thousands of pages of PDFs and put them into this structured database at scale? Well, first, I would like to clarify and show you what we mean by structured rule. So basically, we break legal text into three founding blocks: variables, constants, and logics. Variables are the values that you will plug in later, like group revenue or entity revenue that depends on the tested party. And constants are the numbers directly from the tax laws. For example, the 750 million threshold for CBCR, that's the same for everyone. And then is the logic is how the rule is applied, like with if or else conditions or some simple math calculations, etc. I'll show you an example here. So on the left, you will see a simplified threshold rule for TP doc written in text. And on the right, is exactly the same rule, but written in a structured format that the computer can understand. If you look from the top, you will see the first thing is the case logic. So it's telling the computer there are different scenarios, different cases you need to calculate, not just stop at one. So if we move down, we will see a smaller than logic that is comparing two values. One is a variable of group revenue. Another one is a constant of 100 million euros. So when you enter the actual group revenue, and if it's smaller than the constant 100 million euros, then the computer will return you a constant result that says, okay, TP-doc is not required, and which is exactly what's described in the text on the left. And for the rest of the text, it's also represented in this way on the right. Some are more complicated, some are easier. So next, I will show you how we are using LLMs to extract data in this structured format and how we check that the LLM output follows the format that we assigned. So as we are automating this extraction process with the LLM, to ensure reliability, we need a feedback loop. So we give source text, explicit instructions, and an empty form to the LLM. The form is like a template that says, okay, for these fields, you need to fill it in this way. So the LLM will try to fill this form with the information it finds from the source text, and then it will submit this form to an automatic check to see if it really respects the format we assigned it. So, and this automatic check is verified by deterministic algorithms, not by another LLM. So this is to help us improve the stability of this whole system. So once the result passes this verification, the result will be saved in our database. And if not, the automatic check will tell the LLM which fields are wrong. So the LLM will try to refill the form. And with this feedback, increasing its overall possibility success rate to generate the result in the format that we want. Once we have this pipeline, we compare how LLMs of different sizes behave on this task. So what we want to know is that whether small models are competent enough for this type of task so we can adopt them to reduce cost, or do we absolutely need larger models for this type of task? So for this test, we are using open weight models from Qwen3 family because this is an open source project. So we want to make sure that our results are reproducible in a local environment. And Qwen, they provide a wide range of open weights models for us to make the comparison. But of course, the pipeline is not limited to this type of model. It can be used for any types of model like Mistral or Llama, or even closed LLMs like ChatGPT or Cloud. So as a result, we can see that the smaller Qwen3 14B model has a much higher risk of missing the existence of TP obligations in the source text. It's 30% compared to around 80% for larger models. However, once it detects the existence of certain TP obligation, the average retries it needs is actually not much more higher than the bigger models. So the difference is small. So what it implies is that in an agentic setup, so we can actually use large models to avoid missing obligations. Then we can use smaller models for the rule extraction if we have like very limited compute resources. So at this stage, we are able to confirm that LLM is capable of identifying TP obligations in the source text and also producing structured rules in the correct format and as its output. However, we are not yet able to evaluate the specific quality. So as a first step, we build this quantitative metric, which is text complexity measurement, to evaluate the quality of the result on the macro level. To do so, we need to first understand what it means for a law to become complex in this context. So here are three illustrations of different types of complexity in the way we structure TP rules. On the left, it's a very simple deadline rule, and in the middle, it's a wide rule with many more possible outcomes. And on the right, it's what we call a deep rule because it has many nested if conditions. So the longest, it has to do 3 different types of tests to make sure to know if a documentation is required or not. And this approach of tax complexity measure connects to existing research. So in the paper, Measuring Regulatory Complexity, published in December, just 2 months ago, by Professor Colliard and Georges, they actually also represented regulation as a kind of algorithm, and they break the test into building blocks much similar to our variables, constants, and logics. And what they find is when they measure the complexity from these algorithm formats, it's actually very much line up with the real-world perception of the real tax complexity from the experiments they did. This means that the algorithm view of legal tax actually captures something intrinsic in the rules and not just the wording of the text. So now that we have built these quantitative metrics for complexity, we need to benchmark them against external sources that also measure tax complexity, but with completely different methodologies, so that we can make sure if whether our complexity metrics we got from the LLMs extracted results are valid or just noise. So we did correlation analysis with 3 established external tax complexity indices. One is from the World Bank's Business Ready Index for Taxation. One is Tax Foundation's International Tax Competitiveness Index, and another one is from Accounting for Transparency's Tax Complexity Index. So we found that our measure of complexity correlates with their results, especially when our scope overlaps. And the correlation is actually statistically significant. For example, on the right here, the higher the complexity matrix is, our complexity matrix is, the higher the payment and filing complexity score is from the tax complexity index. And this the same thing apply for the other 2 indices. Just in the middle, it moves with the tax foundations index. It moves in the opposite direction. It's because for them, more complexity means less competitiveness. So it just still makes sense. So this external validation confirms that our algorithm approach reflects at least some parts of the reality. And actually, this complexity measure does not work not just as a validation tool. First, it also helps systemize tax rule extraction itself. So complexity gives us a simple metric that we can use to compare results across different jurisdictions, different sources, or different LLMs. And so it can also flag when an extracted rule looks suspiciously less complex than the underlying text. And second is it supports direct comparisons of different tax regimes. So if we can compare complexity level between legislations or jurisdictions, then tax administrations can help steer the simplification of tax rules more easily, and they can also use it to benchmark against over time with the same metric. So this is actually something we are discussing with some researchers from the European Commission who are working in the context of tax simplifications in Europe. However, there is still a shortcoming of the tax complexity measurements. So the problem is it only serves as a tool for validation on the macro level, but it does not ensure that each individual extracted rules are correct. So for this, we developed like 3 layers of verification to ensure the quality of LLM extracted results. So first, we are working with some of the most experienced tax lawyers in France to analyze and improve the reliability of LLM extracted results. And second, as I said before, we initiated the Open Tax Calendar project, which is community-driven. So the data platform is free to use, but it's also open for corrections for any tax professional. And last, we also use LLM as the judge, agents as automated quality inspector to detect hallucinations, omissions, and also can flag results that need rechecks or new runs or human review. So to wrap up on my part, we think that through layers of verification, LLM can really accelerate turning legal text into structured and computable rules, which is a key to automation in our sector. And now I will hand over to Youssef for a live demo.
So hi, everybody. Like my colleague has just stated, my name is Youssef, and I've been leading software engineering in Algonomia for quite a time now. And lately, I've been leading this project, which is called Open Tax Calendar. So what is Open Tax Calendar? Simply put, it's an open and free database that you may all use to automate some workflow or gather some information. Now, this database contains all data about obligations and jurisdictions, especially thresholds and penalties. And since it is open source and free, you may use it any times to, for example, automate some transfer pricing workflow, which is what we exactly did in one of our private solutions, which I will present right afterwards. Now, if you have some IT guy or you are interested in IT or connecting this database to your solution, you may visit the API access page, which is well documented and in which you may use to connect this database to your solution and extract the information you need. Now, if you are not into IT, you may use an A10. It's completely possible, definitely. But you may also just visit opentaxcalendar.com and just navigate and fetch the information you need. So a little bit about the dashboard of Open Tax Calendars. On the upper left, you have a map upon which, if you click, you will have like a filtering of a table below in which you may have all the information about all obligation for this country. These information are exportable in Excel format, but by clicking in here. And in the dashboard on the upper right, you will have a summary about this country. You can switch between obligations and you can export these data in PDF format by clicking on this button. Now, what are the benefits of making this open source? So like everyone stated this morning and this afternoon, LLMs hallucinate. We all know that. And one way to ensure correctness of this data is to make sure that we create a community of strong specialists like yourself, which are able to contribute directly to this database. Now, how may you contribute? There is many ways. You may, for example, suggest new public sources from which we may extract data. We may suggest corrections about values that already exist and that are already generated by the LLM workflow that Zhengxiao just presented earlier. And you may also audit the source it has been extracted from and rate any values you like and even add a comment. Now, how do we use this solution in our TP automation workflow? Now, this is CTC Leaf. This is a private solution in Algonomia that we sell to our clients, and which is able to ingest financial data and connect to the OTC database. And from the information it gathers from the OTC database and from this financial data, and by running the algorithms that Zhengxiao has described earlier, it may deduce which of these entities are subject to TP documentations and which are not. Now, if you if I click on this button, you will see some loading. And if I visit our TP applications after I have clicked on this button, you will see that very specific objects have appeared. And these specific objects are actually tasks that have been created for only the entities that are subject to TP documentation. And only people who are concerned about these tasks are going to be notified. And only the actions that are needed to be processed by these users are going to be available. Now, for example, if I click on this entity, you will see that in this example, you may load some TP report and either complete it by, let's say, more data. Or, well, I hope you have enjoyed this demonstration, and thank you for listening.
Okay.